Good evening, everyone. Good evening. Welcome back to NEET Elite. Welcome back, everyone. Welcome back to NEET Elite. Hope that you guys are doing great. Well, people, let me know in the chat box if I'm audible and visible to everyone. Yes. Let me know in the chat box if I'm audible and visible to everyone. Give me some thumbs ups from the chat box so that I'll get to know whether I'm audible and visible to everyone. I'm doing great. Yes, let me know in the chat box fast. Yeah. Perfect, guys. Perfect. So as you all must be knowing, today it's going to be the one-shot revision from the chapter mole concept, right? Well, people, Sanjay is saying, sir, use English rather than Hindi. Bro, this is the English channel only, chill. Okay, so in this session, I have come up with a set of problems, and by solving those problems, I'm sure your entire mole concept is going to get revised properly, okay? Right? So before starting the session, so let me tell you, this session is for the ones who are going to write the NEET in 2021, 2022, as well as 2023, right? The session is for everyone, okay? So for the ones who are new to the channel, who do not know me, let me introduce myself. My name is Wassim Sir. I'm your chemistry master teacher right here on this NEET Elite channel. The ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, right? And do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking right here on this NEET Elite channel, yeah? Okay. So people, you can let me know in the chat box if you guys are super duper excited about the session. Just let me know in the chat box if you guys are super duper excited about the session, yeah? I'm doing great, Diksha. I'm doing great. Thank you. Welcome, everyone. Welcome to your NEET Elite. Perfect. Let me know in the chat box if you guys are super duper excited about the session. Let me see the josh of the session first, then only we'll be starting directly with the session, yeah? Okay. Right. Perfect, guys. Perfect. All right, so let's get started directly with the first question, which is on your screen right now. Yes. Look at the question and give it a try on your own. A very simple question, and this was once asked in your NEET examination. I don't remember the year, but this was asked once, okay? See, guys, what the question says. If Na is the Avogadro's number, then the number of valence electrons in 4.2 grams of nitride ion, N3 negative ion, will be, okay? So the question says, if Na is the Avogadro's number, the number of valence electrons in 4.2 grams of nitride ions will be. A very simple question this is. See how to approach this sort of equation. Already, if you have watched the earlier sessions of mole concept, I'm sure you can easily solve it now. Okay, if you have watched the sessions in the beginning, right? Okay, if you have not, then look here. See, guys, first thing, I'm given with 4.2 grams of N3 negative. I'm given with 4.2 grams of N3 negative, right? This is the mass of N3 negative which is given to me. First of all, what I'll be doing over here is I'll be converting the mass of nitride ion into its moles. And I have told you already, whenever you'll be given with the mass of the substance and you're supposed to convert into the moles, how do you do it? Simple. Divide the given mass of the substance by the molar mass of the substance. You'll be getting the number of moles. As simple as that, right? So I'll say number of moles of N tri-negative. It's going to be equal to mass of N tri-negative, which is 4.2 grams, divided by molar mass of nitrogen. All of you must be knowing that is 14, correct? Okay, so from here I'll be getting the number of moles of N tri-negative, right? So the value I think comes out to be 0.3, is that? Right, the value will come out to be 0.3. So I got the number of moles of N tri-negative, number one. Okay, number two, let's calculate number of ions, that means number of particles of N tri-negative. See, I know the number of moles of N tri-negative. Now it's time to calculate the number of particles of N tri-negative. it's going to be equal to 0.3 multiplied by Avogadro's number, yeah? Okay, so these many ions of N tri-negative we have actually, okay? Now after this, what do we need to do? Since we are supposed to calculate the number of valence electrons in N tri-negative, if I talk about N tri-negative, how many electrons will be there? Do I have to calculate electrons? Wait. Yes, we have to calculate valence electrons, okay? First of all, let me write the configuration, just the normal configuration of nitrogen without any charge. If I'll be having nitrogen, its configuration is going to be 2, 5 because its atomic number is 7, right? Its configuration, normal nitrogen configuration is going to be 2, 5, yeah? But right here, it has got tri-negative charge as well. That means it has gained 3 electrons. So in its outermost shell, how many electrons will be there? There will be 8 electrons in the outermost shell of N tri-negative, okay? So there are 8 valence electrons basically in N tri-negative, 8 valence electrons. 2 in the first shell, 8 in the second shell, right? The second shell is the valence shell of this N tri-negative, okay? So people, I can say something like this. I can say one ion of N tri-negative contains how many valence electrons? Contains 8 valence electrons, right? But do I have only one ion of N tri-negative? No, I have got 0.3 Na. I have got 0.3 Na ions of N tri-negative, right? So if one ion of N tri-negative contains 8 valence electrons, so 0.3 Na ions of N tri-negative will contain 8 multiplied by 0.3 Na. The value comes out to be 2.4 Na ions. So there will be total 2.4 Na ions present in 4.2 grams of nitride ion. Yeah, you can let me know in the chat box if it is clear to you. Yes, Shri will be doing the atomic structure also. Yeah, wait for it. No, Hemant, everything will be done. Everything. I'm already currently teaching organic also on this channel. You can check it out. Okay. So let me know fast. Is it clear to everyone? Give me some green signal from the chat box so that I can move on, right? Give me some green signal from the chat box so that I can move on. Short status, you can just drag the video a little back. It will be automatically a replay for you. Shweta, organic chemistry of class 12 will be also done. Let's finish isomerism and hydrocarbons first. Okay. Perfect, guys. I'm moving on to one more question. Yeah. So the answer, valence electrons present in 4.2 grams of nitride ion, it's going to be 2.4 Na. Yeah. Perfect. Let's move on to one more question. A very simple question, and this was also asked once. See what kind of simple question was asked in your some of the competitive examination. I don't remember exactly, but this was asked somewhere. See guys, a very simple and the ordinary question, right? Given the percentage abundances of isotopes of iron are 5%, 90% and 5% respectively, the average atomic mass of iron in percentage will be, okay? Yeah? So guys, see how to solve this one. As per the question itself, it's mentioned that iron has got the 3 isotopes. It has got 3 isotopes, yeah? Which one? The first one is Fe54, the second one is Fe56, the third one is Fe57. These are the 3 isotopes of iron which I'm given with, right? Okay. Now people, I'm given with the percentage abundance of these isotopes as well. The percentage abundance of Fe54 is given to me as some 5%, right? Percentage abundance of Fe56 is given to me as 90, and this one is given to me as 5%, right? I'm given with the percentage abundance of these isotopes as well, correct? So people, can I call this simply as M1? I'll be calling this simply as M2. I'll be calling simply this as M3, right? And percentage abundances, we represent the percentage abundances by A, B, and C respectively, right? And we know, if you remember, whenever I'll be having the element which exists in the form of isotopes, right? We always calculate average atomic mass of that element by the formula MAV is equal to, it's going to be M1 multiplied by A plus M2 multiplied by B plus M3 multiplied by C divided by A plus B plus C, right? So it's going to be M1 multiplied by A plus M2 multiplied by B plus M3 multiplied by C divided by A plus B plus C. And remember at the same time, the sum of the percentage abundances of all the isotopes of a particular element, that's always equal to 100, yeah? Okay, so people, M1 value is given to me as 54, A value is given to me as 5, yeah? Plus M2 value, it's given to me as 56, B value is given to me as 90, plus M3 value is given to me as 57, C value is given to me as 5. Divided by A plus B plus C, that comes out to be 100. Just solve it, get the value of average atomic mass, which I was supposed to calculate, right? So let me show you the exact value of average atomic mass, which you'll be getting from here. It's going to be 55.95%, right? So the average atomic mass of iron, as per the question, will be 55.95%, right? Let me know in the chat box if it is clear to everyone, yeah? Let me know. Yes, Abdul Aziz will be doing that in the next session itself. Don't worry. Yeah? Let me know in the chat box if it is clear to everyone so that I can move on. Just give me some green signal from the chat box, yeah? Exactly. Perfect, guys. So let's move on directly to one more question then, okay? We have got one more question right here. See, look at the question. You can easily solve this one as well, I'm sure. See guys, at 27 degrees centigrade and 1 atm pressure, a given mixture of O2 gas and SO2 gas contains gases in 2:1 volume ratio. Calculate the number of moles present in 20 grams of the mixture. Okay? See what is mentioned in the question and what we are supposed to calculate as per the question. Understand properly what I'm going to say. See guys, basically, you are given with a container, right? And in this container, we are given with two gases. And what are the gases given to us? One is O2 gas and the another one is SO2 gas. Let's call O2 gas as gas 1. Let's call this as gas 2. Okay. So people, in the container right now, I have got a mixture of gas. Yes, I have got a mixture of gas first of all. As per the question, we are given with the mass of this mixture of gas, right? We are given with the mass of the mixture of gas. It's given to me as 20 grams. What am I supposed to calculate? I'm supposed to calculate the number of moles present in 20 grams of this mixture, right? I'm supposed to calculate number of moles present in 20 grams of this mixture. Now the point is, how do we do it? Understand properly what I'm going to say. First of all, am I given with the volume ratio of these gases? Yes, we are given with the volume ratio 2:1, right? This is the volume ratio of the gases in the container, which is given to me, okay? Yes, Hemant, you can watch it. All right, look here, guys. Now, since what we are supposed to calculate? We are supposed to calculate the total moles present in the mixture, which is going to be equal to mass of the mixture divided by molar mass of the gaseous mixture. But molar mass of the gaseous mixture is something which we call as average molar mass of the mixture. That's what we call as average molar mass of the mixture, right? Okay. Now we will see. It's going to be mass of the mixture, it's given to me as 20 grams divided by average molar mass of the mixture. I'll be calculating first. After calculating the average molar mass of the mixture by somehow, I'll put that average molar mass of the mixture value in this equation. I'll be getting the number of moles present in the mixture, which I'm supposed to calculate, right? Now the point is how to calculate average molar mass of this mixture. Well, people, it's mentioned in the question that the mixture which we have, it's present at constant pressure and temperature. The pressure and temperature of the mixture is kept fixed. It's kept constant, right? Okay. If I ask you what is the molar mass of O2, molar mass of O2 is 32 grams per mole and molar mass of SO2 is 64 grams per mole, right? 64 grams per mole, correct? I should be calling this as V1, I should be calling this as V2, okay? Well, people, remember, whenever you'll be given with a mixture of gas, which will be present at constant pressure and temperature, at that time, how do we calculate average molar mass of that gaseous mixture? It's going to be M1V1 plus M2V2 divided by V1 plus V2. As simple as that, right? This is the formula to calculate average molar mass of the gaseous mixture, which will be present at constant pressure and temperature, right? What is the value of M1 which we have? The value of M1 is 32. What is the value of V1? Value of V1 is 2 plus M2 value. M2 value is given to me as 64. The value of V2 is given to me as 2 divided by V1 plus V2. 2 plus 1, that comes out by 3. The value will come out to be 128 divided by 3. So this is basically the average molar mass of the gaseous mixture which I got, right? Okay. Well, people, since we have calculated the average molar mass of the gaseous mixture, I'm going to put the value of average molar mass of the gaseous mixture in this equation. It's going to be 20 divided by average molar mass of the gaseous mixture is 120 by 3. So the value simply will come out to be 60 divided by 128. So these many total moles we have got in this 20 grams of mixture right now as per the equation, yeah? Exactly, the value comes out to be 0.46, yeah? People are saying the value comes out to be 0.46. So total there will be 0.46 moles of the mixture present in 20 grams of it, yeah? Mohammad Rafi, you'll get that soon, okay? Just wait for it. Just let me know in the chat box if it is clear to everyone, so that give me some green signal from the chat box so that I can move on to the next one, yeah? Give me some green signal. Give me some green signal from the chat box so that I can move on to the next one, yeah? Perfect. It's okay, Karthi, it's okay. Yes, Mint, it's V2S1. Yes. All right, let's move on then. Let's move on to one more question, yeah? So let's move on to one more question, and the question is right now on your screen. See, guys, what the question says. Look here. A gaseous mixture contains 60 mole% of carbon dioxide and 40 mole% of oxygen, right? Calculate the average molar mass of the mixture. A very simple question, right? A very simple question. See, guys, as per the question, you have a container, yeah? And in this container, what all gases we have? We have got carbon dioxide. And with this carbon dioxide, you have got oxygen as well in this container, right? Okay. Well, as per the question itself, or let me call this carbon dioxide as gas 1. Let me call this oxygen as gas 2, right? First thing, the molar mass of carbon dioxide, which I'm representing by M1, that will be simply 44 grams per mole, right? The molar mass of oxygen, that's going to be 32 grams per mole, right? Okay. Now people understand. What am I given with? I'm given with the mole% of carbon dioxide and mole% of oxygen as well, right? Mole% of carbon dioxide. I'm writing it over here. See, I'm given with two terminologies. I'm given with mole% of carbon dioxide. Carbon dioxide I'm representing by number 1. So mole% of number 1, mole% of carbon dioxide is given to me as how much? It's given to me as 60. Similarly, mole% of second one, which is oxygen, it's given to me as 40. Correct? These are the terms which are given to me. Now. See, guys, a very simple question this is. First thing, let's assume the mole fraction of carbon dioxide in the container is represented by Chi1. Let's assume mole fraction of oxygen in the container is Chi2, right? And if you remember, mole% of gas 1 will be simply equal to mole fraction of 1 multiplied by 100. Similarly, I can say mole% of gas 2 in the mixture is going to be equal to mole fraction of gas 2 multiplied by 100, right? I hope you know it. Yeah? Very simple. Now, people, if you remember, in order to calculate average molar mass of the gaseous mixture, we have got one formula as M1 Chi1 plus M2 Chi2, right? This is one more result by means of which we can directly calculate average molar mass of the gas. Yeah? So the question is almost done. See. Mole% of gas 1 is, let me erase the formula first. See, mole% of gas 1 is 60. Mole% of gas 1, instead of it, I'll be writing mole fraction of gas 1 multiplied by 100. This value is 60. Similarly, mole% of gas 2 is going to be mole fraction of gas 2 multiplied by 100, right? This value is equal to 40. So from here, I can get the value of Chi1, which is going to be 0.6. From here, I can get the value of Chi2, which is going to be 0.4, right? When you have Chi1, Chi2, you're done with the equation. Yeah, I believe. Okay, so it's going to be M average molar mass of the gaseous mixture. It's going to be equal to M1 Chi1 plus M2 Chi2, right? M1 value is given to me. M1 value is given to me as 44. Chi1 value is given to me as 0.6 plus M2 value, it's given to me as 32 multiplied by Chi2 value is given to me as 0.4. Just calculate it. I think you get the value as 39.2. So 39.2 grams per mole is going to be the molar mass, average molar mass of the gaseous mixture, right? Right. Let me know in the chat box if it's clear to you. So you get the answer of average molar mass of the gaseous mixture as 39.2 grams. Yeah? Okay. Shri, for the mixture, we always define a term average molar mass. We don't define total molar mass. Okay. Yeah, is it clear to everyone? Perfecto. So let's move on then directly to one more question. A very simple and ordinary question from stoichiometry, right? A very simple and ordinary question. and all of you must remember its answer as well, because I have shown this question in the regular sessions as well, if you remember. Okay, see guys, the question is, calculate the mass of O2 produced on heating 12.25 grams of KClO3. First of all, I'm heating KClO3. Remember, when we heat KClO3, it gets converted into KCl, and with this you get oxygen gas as well. Yeah, okay. So first of all, KClO3, it's in solid form. So KCl is also in solid form. Remember, O2 is in gaseous form. First thing which I'll be doing, I'll be balancing the reaction. This should be 2 times, this should be 2 times, this should be 3 times. I have balanced the reaction, yeah? Now people understand. I'm given with the mass of KClO3, right? First of all, I'll be converting the mass of KClO3 into its moles. So number of moles of KClO3 is going to be equal to mass of KClO3 divided by molar mass of KClO3, which is 122.5. The value comes out to be 0.1. So there are basically 0.1 moles of KClO3, right? So we have got basically 0.1 moles of KClO3. Now people, use the stoichiometry. The question is almost done and dusted. See, the stoichiometry coefficient right here is 2, right here is 3. Can I say 2 moles of KClO3? Can I say 2 moles of KClO3? It gives 3 moles of oxygen. Yeah, 3 moles of oxygen. So I can say 1 mole of KClO3 should give me 3 by 2 moles of oxygen. So 0.1 moles of KClO3 should give me 3 by 2 multiplied by 0.1. The value will be 0.15 moles of oxygen. So 0.15 moles of oxygen are liberated when we heat 12.25 grams of KClO3, right? So I got to know the number of moles of oxygen which are liberating right now, it's equal to 0.15. Well people, if you got to know the number of moles of oxygen liberated, I can easily calculate the mass of oxygen liberated, which is going to be equal to number of moles of oxygen liberated multiplied by molar mass of oxygen, right? So number of moles of oxygen liberated is nothing, that is 0.15. Molar mass of oxygen is 32. The value will be, I guess, 4.8 grams, right? So 4.8 grams of O2 is liberated on heating 12.25 grams of KClO3 at STP, yeah? Right? Right. Let me know in the chat box if it's clear to everyone so that I can move on to the next one, yeah? Let me know in the chat box if it's clear to everyone, yeah? Okay. So let's move on then. Let's move on to one more question, which will be on your screen. Okay, this is the question on your screen. Look at the question. 25 grams of an unknown hydrocarbon upon burning produces 88 grams of carbon dioxide and 9 grams of water. Determine the mass of carbon and hydrogen in this unknown hydrocarbon. Okay, look at the question. We have got some hydrocarbon, right? We are given with some hydrocarbon. Okay, we are given with some hydrocarbon. Hydrocarbon is CXHY. Okay, now what am I doing? I'm just doing the combustion of this hydrocarbon. I'm doing the combustion of hydrocarbon, right? And combustion of hydrocarbon, it always leads to the formation of carbon dioxide gas, and with this you get H2O gas as well. This is the reaction when we do the combustion of hydrocarbon, yeah? Now first of all, let's try to balance it. See, this is X. So the stoichiometric coefficient right here is X, over here is going to be Y by 2, and the stoichiometric coefficient of oxygen is going to be X plus Y divided by 4, right? Now we will look at this equation carefully. Look at this equation carefully. Understand. See, can I say whatever carbon was present in this hydrocarbon, that entire carbon is reaching into carbon dioxide? Whatever hydrogen was present in this hydrocarbon, that entire hydrogen is finally reaching to this water, okay, right? See, from the balanced chemical equation, you can see whatever carbon was there in the hydrocarbon, that entire carbon will be present in carbon dioxide, right? Similarly, whatever hydrogen was there in hydrocarbon, that entire hydrogen will be present in water, okay? Now, as for the question itself, what are we given with? See, 25 grams of an unknown hydrocarbon upon burning produces 88 grams. So basically, as per the question, we are having right now 88 grams of carbon dioxide, and at the same time we are having some 9 grams of water as well. Okay, so when 25 grams of an unknown hydrocarbon undergoes combustion, Okay, it leads to the formation of 88 grams of carbon dioxide and 9 grams of water as per the question itself. Okay. Now what I need to do, how will I be solving this? How will I be solving this? Understand. See guys, if you talk about carbon dioxide, what is the molar mass of carbon dioxide? So first of all, if I particularly talk about carbon dioxide, can I say 1 mole of carbon dioxide contains 1 mole of carbon? 1 mole of carbon dioxide contains 1 mole of carbon, as simple as that, right? Similarly, 1 mole of water contains 2 moles of hydrogen, right? 1 mole of water contains 2 moles of hydrogen atoms, I must say. Okay, understand what I'm going to do. See guys, I'll say first of all, if I talk about carbon dioxide, what is the molar mass of carbon dioxide? 44 grams. That means 44 grams is the mass of 1 mole of carbon dioxide. Can I say 44 grams of carbon dioxide contains 12 grams of carbon as per the stoichiometry? 12 grams of carbon, as simple as that, yeah? Okay, see, 1 mole of carbon dioxide contains 1 mole of carbon. That means 44 grams of carbon dioxide contains 12 grams of carbon, yeah? So can I say 1 gram of carbon dioxide contains 12 divided by 44 grams of carbon? Okay, but do I have only 1 gram of carbon dioxide? No, I have 88 grams of carbon dioxide. Can I say 88 grams of carbon dioxide will contain 12 divided by 44 multiplied by 88? The value comes out to be 24 grams of carbon. Right? So basically in this carbon dioxide, you got to know that you have got some 24 grams of carbon present. There are some 24 grams of carbon present in this carbon dioxide right now. Okay, you can say there are 24 grams of carbon present in 88 grams of carbon dioxide, right? And whatever carbon is present in this carbon dioxide, that entire carbon has come from this hydrocarbon. So in this hydrocarbon, actually you got to know that there are 24 grams of what? 24 grams of carbon. Correct? You got to know it, right? Okay. Similarly, can't we calculate the mass of hydrogen as well? Can't we calculate the mass of hydrogen as well in the hydrocarbon, right? Simple. What did you get to know? I just changed the slide, sorry. See, we had total 25 grams of unknown hydrocarbon, right? And 25 grams of unknown hydrocarbon, we got to know there are some 24 grams of carbon present in it, right? Total, there were 25 grams of hydrocarbon containing 24 grams of carbon. So there'll be some 1 gram of hydrogen as well, right? Okay, there'll be 1 gram of hydrogen as well in this. Okay, the question is done and dusted, right? Right. Let me know in the chat box if it is clear to everyone. Aditya, this is the general way of balancing the hydrocarbon combustion reaction, okay? Right? Perfect. You have to remember it. Remember the combustion of every hydrocarbon, it always leads to the formation of carbon dioxide and water. Okay, you need to remember this. Priyanshu, you need to start it from the mole concept, okay? Abdul, I'll be doing that soon. Just wait for it. Just focus on the session. Okay, let's move on to one more question. This is one more simple and ordinary question which we have. You can solve this question. Calculate the volume of carbon dioxide. Calculate the volume of carbon dioxide produced at STP by complete combustion of 570 grams of octane, right? I've got octane. What is the formula of octane? C8H18, right? I'm doing the combustion of octane. Again, I'm doing the combustion of hydrocarbon. Leads to the formation of carbon dioxide gas, and with this carbon dioxide gas, you get water as well. Okay. First of all, let's try to balance this reaction. Let's try to balance this reaction. Let's try to balance the reaction, okay? So first of all, if you try to balance it, it should be 8 times. This should be 9 times. This should be 25 divided by 2 times, okay? When you balance it, because few minutes back, I told you how to balance the general hydrocarbon combustion reaction, CXHY. The stoichiometric coefficient of oxygen is going to be X plus Y by 4. This is going to be X, this is going to be Y by 2, right? We know it. Now we will understand. I'm good with some 570 grams of octane. So first of all, I'm going to calculate the number of moles of octane, which is going to be equal to mass of octane, which is 570, divided by molar mass of octane. When you will find out, it is going to be 114. The value comes out to be 5. So there are basically 5 moles of octane, right? There are basically 5 moles of octane present in 570 grams of it. Okay, now use the stoichiometry. See, stoichiometric coefficient right here is 1. Over here it's 8. Okay, so 1 mole of octane contains, 1 mole of octane gives 8 moles of carbon dioxide, I must say. Yeah. 1 mole of octane gives 8 moles of carbon dioxide. So I can simply say 5 moles of octane are going to produce 8 multiplied by 5. The value is 40 moles of carbon dioxide. So you got to know 40 moles of carbon dioxide are being liberated, right? So I can say number of moles of carbon dioxide liberated over here, it's going to be 40. But am I supposed to calculate the moles of carbon dioxide liberated? No, I'm supposed to calculate the volume of carbon dioxide liberated. So volume of carbon dioxide liberated will be equal moles of carbon dioxide liberated multiplied by 22.4. The value comes out to be 896 liters. So basically there are 896 liters of carbon dioxide which are being liberated on doing the combustion of some 570 grams of octane, right? Yes, Zahid, you can go for it. You can let me know in the chat box if everything is clear till here so that I can move on. And the ones who have not liked the session yet, do not forget to like the session, do not forget to share the video with your friends, and do not forget to subscribe to the channel as well, yeah? Latha, you have to remember these reactions, okay? It's a simpler one, by the way. Right? Okay. Let's move on to one more. Okay. Calculate the mass of H3PO4, which contains 0.25 moles of oxygen atoms. Okay, understand. See how this question is to be solved. Calculate the mass of H3PO4 which contains 0.25 moles of oxygen atoms. So first of all, if I talk about H3PO4, can I say something like this? Can I say 1 mole of H3PO4? 1 mole of H3PO4 contains 4 moles of oxygen atoms. Yeah? 1 mole of H3PO4, it contains 4 moles of oxygen atoms, right? Or I can just reverse the statement. Can I say 4 moles of oxygen atoms, 4 moles of oxygen atoms are present in 1 mole of H3PO4, yeah? Are present in 1 mole of H3PO4, correct? I can say that as well. I just reverse the statement. Okay? See guys, 4 moles of oxygen atoms are present in 1 mole of H3PO4, correct? Can I say 1 mole of oxygen atoms, 1 mole of oxygen atoms will be present in 1 by 4 moles of H3PO4 by using the unitary method? Okay, I got to know 1 mole of oxygen atoms are present in 1 by 4 moles of H3PO4. So as per the equation, 0.25 moles of oxygen atoms will be present in 1 by 4 multiplied by 0.25 moles of H3PO4. So basically I got the number of moles of H3PO4 which contains 0.25 moles of oxygen atoms, right? So I got to know the number of moles of H3PO4 containing 0.25 moles of oxygen atoms is 1 by 4 multiplied by 0.25 again is 1 by 4, right? So it's going to be 1 by 16. So 1 by 16 moles of H3PO4 will be containing 0.25 moles of oxygen atoms, right? But am I supposed to calculate the moles of H3PO4 containing 0.25 moles of oxygen atoms? No. I'm supposed to calculate mass of it, right? I'm supposed to calculate the mass of H3PO4 which contains 0.25 moles of oxygen atoms, right? Since I got the moles of H3PO4, I can simply say the mass of H3PO4 containing 0.25 moles of oxygen atoms is going to be equal to 1 by 16 multiplied by 1 by 16 is, these are the moles of H3PO4 multiplied by molar mass of H3PO4 comes out to be 98. The value will be approximately something as 6.1 grams. So I got to know something as 6.1 grams of H3PO4 contains 0.25 moles of oxygen atoms, right? 6.1 grams of H3PO4 contains 0.25 moles of oxygen atoms. Let me know in the chat box if it's clear to you, yeah? Hanji Ariba, yes, you're right. So let me know in the chat box if it's clear to everyone, yeah? Yes, I take the live sessions daily on this channel, yeah. This channel as well as JE channel. Okay. So should we move on? Give me some green signal from the chat box so that I'll move on directly, yeah? Give me some green signal from the chat box so that I'll move on. Okay. All right. Perfecto. Let's move on then. Let's move on to one more question. See what the question is. The weight of iron, okay, the weight of iron which will be converted into its oxide, Fe3O4, by the action of 18 grams of steam on it will be, okay. So first of all, you should know when iron reacts with H2O, steam, right, it leads to the formation of Fe3O4, and with that Fe3O4 you get hydrogen gas as well, okay. See, this is the reaction which is going to happen. Understand. The reaction is Fe plus H2O gas, it gives Fe3O4 plus H2 gas, correct? So if I try to balance the reaction first, this should be 3 times, this should be 4 times, this should be 1, this should be 4 times, right? Now the reaction is balanced. Now the reaction is balanced, right? Now we'll understand how will I be solving this. First of all, if I ask you, what is the molar mass of iron? 56 grams. That means mass of 1 mole of iron is 56 grams. But right here I have 3 moles. So what is going to be the mass of 3 moles of iron? 3 multiplied by 56. That's 168 grams, right? What is the molar mass of water? You will simply say 18 grams. 18 grams is the mass of 1 mole of water, right? But I have 4 moles of it. So 18 multiplied by 4 comes out to be 72 grams, correct? Okay. What am I supposed to calculate? I'm supposed to calculate the weight of iron, right? That will be converted into its oxide by the action of 18 grams of steam. Okay, see. Can I say 72 grams of water reacts with 168 grams of iron? 72 grams of water reacts with 168 grams of iron. Okay, so can I say 1 gram of water reacts with 168 divided by 72 grams of iron, right? Or let me write it for you so that there won't be any sort of confusion at all. I can say something like this: 72 grams of steam, that is water, right? It reacts with basically 168 grams of iron. Okay, so I can say 1 gram of water, it reacts with 168 divided by 72 grams of iron. Okay, so if 1 gram of steam is reacting with these many grams of iron, I can simply say 18 grams of steam. 18 grams of steam will be reacting with 168 divided by 72 multiplied by 18 grams of iron. So this is basically the mass of iron that has participated in the reaction. So this is going to be 18.1, this 18.4. When you solve it, you get the value as 42 grams. So you got to know simply as with the 18 grams of steam, you should have 42 grams of iron over here. Yeah, right? So you got to know simple, very simple thing. You got to know with your 18 grams of steam, you should have what? You should have 42 grams of iron over here. Okay? As simple as that, right? Lenovo, that will be done this week only, okay? Perfect. Yes, Vivek. This right bottom is my Instagram handle, yeah. Perfecto. Let's move on to one more. The question is again a simpler one. See, how many grams of NO2 are required to produce 25.2 grams of HNO3 at STP? Okay. See guys, you're given with a reaction. The reaction is something like this: 3 times NO2 plus what? Plus H2O. It gives 2 times HNO3. And with this HNO3, you get NO gas as well, okay? The reaction is balanced, okay? It's given in the equation, the reaction is balanced, right? Now, as per the question, how many grams of NO2 are required? How many grams of NO2 are required to produce 25.2 grams of HNO3? To produce 25.2 grams of HNO3, right? See how this question is to be solved. First of all, if I ask you what is the molar mass of NO2? Molar mass of NO2. Nitrogen 14, O2 is 32, 14 plus 32 means 46, right? 46. So molar mass of NO2 is 46 grams. Or I can say 46 grams is the mass of 1 mole of NO2. But right here I have 3 moles of NO2. So 46 multiplied by 3. These many grams of NO2 we have right here. Okay. So 46 multiplied by 3. How much it comes? 3, 6, 18, 3, 4, 12. 128 grams, right? So I can say mass of 3 moles of NO2 is going to be 128 grams, correct? Okay, right? Now if I ask you, what is the molar mass of HNO3? Molar mass of HNO3 is going to be 63 grams, or I can say 63 grams is the mass of 1 mole of HNO3, but over here I've got 2 moles. So mass of 2 moles are going to be simply 2 multiplied by 63, that means 126 grams. 126 grams is the mass of 2 moles of what? Mass of 2 moles of HNO3. Oh, this is 138, right? Okay. So I got to know something like this. 126 grams of HNO3. From the stoichiometry of the reaction, I got to know 126 grams of HNO3 are produced from 138 grams of NO2. Yeah, this is something which I got to know. 126 grams of HNO3 are produced from 138 grams of NO2. Or I can say 1 gram of HNO3 is produced from 138 divided by 126 grams of NO2. Yeah, so I can say something like this. I can say 25.2 grams of HNO3. I can say 25.2 grams of HNO3 are produced from 138 divided by 126 multiplied by 25.2 grams of NO2. Right? So this is the mass of NO2 which I was supposed to calculate, right? When you calculate it, you get the value exactly as 27.6 grams, okay? You get the value as 27.6 grams. So what is meant by this? What is meant by this? I'll say something like this. 25.2 grams of HNO3 are produced from 27.6 grams of NO2, right? Or I can clearly say, in this reaction, 27.6 grams of NO2 are participating, yeah? You can let me know in the chat box if it is clear to you. Yeah? Just let me know in the chat box if it is clear to you. Right? Sanjay, you can follow this as well, okay? Okay, let's move on to one more. This one more question, and I'm sure we have solved this question in the normal classroom itself. 4 times HCl plus MnO2 gives MnCl2 plus H2O plus Cl2, okay? How much HCl is needed for complete reaction with 69.6 grams of MnO2, right? How much HCl is needed for complete reaction? How much HCl is needed for complete reaction with 69.6 grams of MnO2? Okay. And the molar mass of MnO2 is given to me as 87 grams per mole, right? Yeah? Right? See guys, how this question is to be solved. See, first of all, if I ask you what is the molar mass of HCl, you will simply say 36.5 grams, right? 36.5 grams is the mass of 1 mole of HCl, but right now I have got 4 moles of HCl. So what is going to be the mass of 4 moles of HCl? That is 36.5 multiplied by 4. So mass of 4 moles of HCl is going to be this much, right? What about the molar mass of MnO2? It's given to me as 87 grams per mole, right? Or 87 grams per mole is the molar mass. It is the mass of 1 mole of MnO2 over here, right? Okay. So can I say something like this? As per the stoichiometry of the reaction, can I say 87 grams of MnO2? As per the stoichiometry, I got to know 87 grams of MnO2 reacts with 36.5 multiplied by 4 grams of HCl. Okay. 87 grams of MnO2 reacts with these many grams of HCl. Correct? So can I say 1 gram of MnO2 reacts with 136, sorry, it's not 136, it's 36. Reacts with 36.5 multiplied by 4 divided by what? Divided by 87 grams of HCl. Yeah? So I got to know 1 gram of MnO2 reacts is the term, right? Reacts with these many grams of HCl, right? So can I say 69.6 grams? 69.6 grams of MnO2 reacts with 36.5 multiplied by 4 divided by 87 multiplied by 69.6 grams of HCl. Just calculate it. These many grams of HCl will be reacting with 69.6 grams of what? 69.6 grams of MnO2, right? Okay. What is the value coming out to be? People are saying it's 116.8. Okay. So 116.8 grams of HCl are needed to react with 69.6 grams of MnO2 as per the question. You can let me know in the chat box if it's clear. You can let me know in the chat box if it's clear. Let me know fast, yeah? Should I be moving on to the one more question? Should I be moving on to one more question fast? Right? Okay, perfect. So let's move on to one more question. Just a second. Okay, this is one more simpler question. You can solve this as well, I'm sure. Calculate the number of moles of oxygen atoms present in 3.2 grams of Na2SO4.2 times water. Calculate, it's a simple question, guys. Calculate the number of moles of oxygen atoms present in 3.2 grams of Na2SO4.2 times water. So I've got something as 3.2 grams. I'm given with 3.2 grams of Na2SO4.2 times H2O, correct? Its molar mass is given to me as per the question itself, right? Its molar mass is given to me as 178 grams per mole. This is the molar mass of Na2SO4.2 times water, right? Now we will how to solve this one. See, first of all, what is the mass of the compound given to me? I'm given with 3.2 grams. Let's first of all calculate the number of moles of the compound. It's going to be number of moles of what? Number of moles of Na2SO4.2 times H2O. It's going to be equal to mass of the compound, which is 3.2 grams, divided by molar mass, which is 178 grams, right? Okay, so these many moles of the compound we have. Okay. Now people, see, just look at it carefully. Can I say 1 mole of Na2SO4? 1 mole of Na2SO4.2 times water. Can I say it contains 4 plus 2, right? 4 plus 2, 6. So 1 mole of Na2SO4.2 times water contains 6 moles of oxygen atoms. 6 moles of oxygen atoms, I can say this, right? Okay. So I can say 1 mole of Na2SO4.2 times water, it contains 6 moles of oxygen atoms. But do I have only 1 mole of this compound? No. I have got how many moles? I have got 3.2 divided by 178. So 3.2 divided by 178 moles of the compound will contain 6 multiplied by 3.2 divided by 168 moles of oxygen atoms. Right? So I got to know something like this. I got to know these many moles. I got to know these many moles of oxygen atoms are present in 3.2 grams of Na2SO4.2 times water. Right? Well, people are saying it's approximately coming to me as 0.04. Is that 0.04 or 0.1? What is it exactly? Can you let me know in the chat box fast? 0.1 people are saying. Okay. So I got to know 0.1 moles of oxygen atoms are basically present in 3.2 grams of the compound. Yeah? Okay. Perfecto. Let's move on to one more. Yeah? This is one more question over here. Okay. This question is based on principle of atom conservation. Yeah? This question is based on the principle of atom conservation, POAC method. Right? Now, 27.6 grams of K2CO3 was treated by a series of reagents so as to convert all its carbon to K2ZN3FeCN6. Calculate the weight of product formed. Okay. See guys, as per the question, we have got some K2CO3. It is reacting with some series of reagents, A plus B plus something, series of reagents. You have no idea what the reagents are, right? 27.6 grams of K2CO3 was treated by a series of reagents so as to convert all its carbon. Whatever carbon was present in K2CO3, that is getting converted into the product. And the product is K2ZN3FeCN6 whole twice, right? This is the product. Okay, this is the product which is given to me. As per the question, whatever carbon was there in K2CO3, entire carbon is reaching this product, right? So first of all, can I balance the reaction? I won't be able to balance the reaction first of all. Why? Because I'm not given with other reagents as well. Okay, so without balancing the equation, I have to solve it, right? I'll be using the POAC method, right? And POAC equation I'll be writing for example, carbon atoms, right? Why am I writing the POAC equation for carbon atoms? Because it's mentioned in the equation that carbon is remaining conserved, right? Carbon is remaining conserved. So first of all, how many carbon atoms do we have here? 1. So I'm writing 1 multiplied by number of moles of this whole compound, number of moles of this whole K2CO3, right? Okay, instead of this arrow, I'm writing equal to sign. How many carbon atoms do we have right here? It is 6 2s are 12. 12 carbon atoms. So 12 multiplied by number of moles of this whole compound. This is the product basically. So I'm writing 12 multiplied by number of moles of product. Yeah, something like this. Okay. Now people, see, Can I first of all calculate the number of moles of K2CO3? It's going to be equal to mass of K2CO3, which is given to me as 27.6, divided by molar mass of K2CO3 is 138. So these many moles of K2CO3 we have, correct? So I've got a simple equation as I got number of moles of product is equal to number of moles of K2CO3 divided by 12, right? Number of moles of K2CO3 are given to me as 27.6 divided by 138, and in the denominator you have got 12. So these many moles of product are getting formed first of all, right? Right? These many moles of product are getting formed right here. Well, people, am I supposed to calculate moles of product or mass of product? I'm supposed to calculate mass of product formed. I can say mass of product formed will be equal to number of moles of product formed multiplied by molar mass of product, right? Number of moles of product formed is 27.6 divided by 138 multiplied by 2 multiplied by molar mass of product. Molar mass of this whole compound is going to be 698 grams per mole. Just solve it. Just solve it. You'll be getting the mass of product which has got formed over here as per the equation. Yeah? Right? POAC stands for Principle of Atom Conservation. You just go to the actual sessions, right? You just go to the actual sessions. In the actual sessions, I have discussed POAC in detail, right? So Karthik says the answer comes out to be 11.63, is that? Okay, something as some 11 grams. Okay, let me keep it as some 11 grams. Some 11 grams of product will get formed from 27.6 grams of K2CO3, yeah? Okay, let's move on to one more question then. Okay, this is one more question. It's a sequential reaction which is given to me. It's a sequential reaction. Yes, Soumya, it's complete revision. Okay. See guys, this is a sequential reaction, understand. First of all, what I'll be doing, CaC2 plus H2O gives calcium oxide plus C2H2. The C2H2 which gets formed in the first reaction, that again reacts with H2, leads to the formation of C2H4. This C2H4, N molecules of C2H4 forms a compound called as polyethylene, okay? Right? This is the polyethylene which is getting formed. Calculate the mass of polyethylene formed that can be produced from 10 kg of calcium carbide. So people, what I'll be doing over here, see. First of all, see, understand. We had, on the reactant side, we had carbon only in this calcium carbide, right? That entire carbon is reaching this product, right? This product is reacting with H2 and forming C2H4. So whatever carbon was with C2H2, that is finally reaching here. And whatever carbon was here with N molecules of C2H4, that's reaching finally here. So can I say, in short, whatever carbon was there in CaC2, that entire carbon is reaching into this product. So I'll say carbon is remaining conserved over here, right? Carbon is actually remaining conserved over here. Okay, so I'll be simply writing the POAC equation for carbon because carbon is simply remaining conserved over here. Whatever carbon was there in CaC2, that entire amount of carbon is finally reaching into this polyethylene. Yeah. So what I'll be doing right here, I'll be writing CaC2 and at the end, I'll be writing the product, which is polyethylene, right? C2H4 and its N molecules, correct? Okay, I mean multiplied by N. This is what we call as polyethylene. So I'll be writing the POAC equation for carbon because carbon is remaining conserved as per the equation. See, now first of all, how many carbon atoms do we have right here? 2. So 2 multiplied by number of moles of this whole compound, number of moles of CaC2. Instead of this arrow, I'll be writing equality sign. So how many carbon atoms do we have in this polyethylene? Is it 2 carbon atoms or 2 N carbon atoms? These are 2 N carbon atoms multiplied by number of moles of this polyethylene. Yeah. So people, from here, what can I get? See, first of all, am I given with the mass of calcium carbide? Yes, I'm given with the mass of calcium carbide as 10 kgs. So first of all, I'll be calculating the number of moles of CaC2, which is going to be equal to mass of calcium carbide, that is 10,000 grams, divided by molar mass of CaC2, that's 64. So these many moles of CaC2 we have. These many moles of CaC2 we have, right? Okay. So it's going to be 2 multiplied by number of moles of calcium carbide, that is 10,000, divided by what? Divided by 64, right? Is equal to what? 2N multiplied by number of moles of polyethylene. Okay. So this 2 got cancelled. Put this N over here in the denominator. You got something as number of moles of polyethylene which are getting formed over here. It's going to be simply 10,000 divided by 64N. So these many moles of polyethylene are getting formed. But am I supposed to calculate number of moles of polyethylene? Yeah. I'm supposed to calculate number of moles of polyethylene ki mass of polyethylene. I'm supposed to calculate mass of polyethylene, which is going to be equal to number of moles of polyethylene multiplied by molar mass of polyethylene. Yeah. So it's going to be equal to number of moles of polyethylene, that is 10,000, divided by 64N multiplied by molar mass of polyethylene. See, what is the molar mass of this polyethylene? Carbon 2, that means 12 to 24, 24 plus 4 is 28, 28 multiplied by this N. So molar mass of this polyethylene is 28N. This N got cancelled, just solve it, get the value in grams. So these many grams of polyethylene have got formed at the end of the reaction, right? Let me know in the chat box if it is clear to everyone, yeah? Let me know fast. Right? Let me know fast. So people are saying 4375, okay? So 4375 grams of polyethylene are getting formed at the end of the reaction, which I was supposed to calculate, yeah? Yes, Sir Ravnan, yes, you can watch it. Right? Okay. Perfect, guys. So let's move on to one more question then. On starting with 2 moles each of reactants, how many? See, the question is based on the limiting reagent, yeah? The question is based on the limiting reagent. How do we solve this sort of equation? See, guys, I'm given with the balanced chemical equation, right? And the balanced chemical equation is 6 times LH plus 8 times BF3. It gives 6 times LiBF4. And with this you get B2H6 as well. This is a balanced chemical equation which is given to me, right? Now people, at time t is equal to 0 when the reaction has not started, I'm given with the moles of each reactants. I'm given with 2 moles of each reactants. I've got 2 moles of LH and I've got 2 moles of BF3 as well. So initially when the reaction has not started, there will be no product formation at that time because the reaction has not started yet. Reactants have not reacted and formed the product yet, okay? So people, what I'll be doing, remember, whenever you'll be given with the amounts of reactants, whenever you will be given with the amounts of all the reactants, at that time, we'll be using the concept of limiting reagent. Now, it's time to identify which one is the limiting reagent, yeah? And how do we identify which one is the limiting reagent? See, divide the given number of moles of reactants by their respective stoichiometry coefficients, 6 and 8, okay? The value comes out to be 1 by 3, the value comes out to be 1 by 4. I'll say 1 by 4 is less than 1 by 3. 1 by 4 is less than 1 by 3, right? The lesser value, the one which is having the lesser value, that's going to be your limiting reagent. So BF3 is your limiting reagent right here because its value comes out to be lesser, okay? So I got to know BF3 is my limiting reagent, yeah? Well, people, if BF3 is my limiting reagent, so I'll be left with 0 moles of BF3 because limiting reagent is the one, okay, which gets completely consumed in the reaction. What am I supposed to calculate? I'm supposed to calculate the moles of B2H6 that have got formed, right? How to calculate the moles of B2H6 that would have got formed at the end of the reaction. Yeah, how do I do it? Simple. I'll be starting from the limiting reagent. Its stoichiometric coefficient is 8. The stoichiometric coefficient of B2H6 is 1. So can I say 8 moles of limiting reagent? As per the stoichiometry, 8 moles of limiting reagent, which is BF3, it produces 1 mole of B2H6. It produces 1 mole of B2H6. So 1 mole of BF3 will produce 1 divided by 8 moles of B2H6. So I can say 2 moles of BF3 will be producing 1 divided by 8 multiplied by 2 moles of B2H6. The value comes out to be 1 by 4. 1 by 4 means 0.25. So 0.25 moles of B2H6 would have got formed at the end of the reaction. As simple as that, right? This is something which I was supposed to calculate, yeah? So I was supposed to calculate the number of moles of B2H6 that would have got formed at the end of the reaction. You can let me know in the chat box if everything is clear till here, yeah? Just let me know in the chat box if everything is clear so that I can move on to the next one. Let me know fast. Let me know fast, yeah? Right? Perfect. Okay, let's move on to one more then. Let's move on to one more. Okay, one more question. This was also once asked in your JE. Okay, the same question. See guys, you can solve this question as well, I'm sure. 0.1 mole of BaCl2. We have got BaCl2, right? Reacting with Na3PO4. And remember, when BaCl2 reacts with Na3PO4, it leads to the formation of Ba3PO4 whole twice. Oh, okay, the reaction is also given to you. Ba3PO4 whole twice and NaCl, correct? See guys, at time t is equal to 0, in the beginning, 0.1 moles of BaCl2 are mixed with 0.3 moles of Na3PO4, right? This is going to be 0, this is going to be 0 because the reaction has not started yet. I'm talking about time t is equal to 0, correct? Now people, whenever you are given with the amounts of all the reactants, at that time we use the concept of limiting reagent, yeah? And what is the first step to use the limiting reagent concept? We are supposed to balance the reaction. Is the reaction balanced? Yes, the reaction is balanced. This is 3, 2, this is 1, this is 6, right? Now it's time to identify the limiting reagent. And how do I identify the limiting reagent? Simple. Divide the given moles by their respective stoichiometry coefficients, which is 3 and 2. The value over here comes out to be 0.033. The value over here comes out to be 0.15. Which value is lesser? This value is lesser. So simply your BaCl2 is going to be your limiting reagent. So you got to know BaCl2 is the limiting reagent, correct? If BaCl2 is the limiting reagent, at the end I'll be having 0 moles of BaCl2 left because it would have got completely consumed in the reaction, yeah? Right? Now, what do I need to calculate? I need to calculate the moles of Ba3PO4 whole twice formed. I need to calculate the moles of Ba3PO4 whole twice formed. See, these many moles, moles of Ba3PO4 whole twice formed, I need to calculate. Now, I'll be using the simple stoichiometry, right? I'll be starting from the limiting reagent, correct? I'll say 3 moles, as per the stoichiometry, 3 moles of the limiting reagent. I'll say 3 moles of BaCl2, yeah? 3 moles of BaCl2 gives 1 mole of Ba3PO4 whole twice. Okay, 3 moles of BaCl2 gives 1 mole of Ba3PO4 whole twice. Can I say 1 mole of BaCl2 gives 1 by 3 moles of Ba3PO4 whole twice? Can I say 0.1 moles of BaCl2 will be giving me 1 by 3 multiplied by 0.1. The value will be 0.033. So these many moles of Ba3PO4 whole twice would have got formed at the end of the reaction, which I was supposed to calculate, right? So these many moles of Ba3PO4 whole twice would have got formed, right? You can let me know in the chat box if it's clear to everyone, yeah? Kishore, I'll be continuing the solution chapter maybe 2 days afterwards, yeah? Right? Let me know in the chat box if it's clear to everyone so that I can move on, yeah? Right? So that I can move on. Okay? Yeah? Okay, see, this is a similar kind of question and you guys are going to give it a try. I'm not going to show you this one. There's a similar kind of question which can be done on the basis of limiting reagent concept, yeah? Okay? This is the similar kind of question which you are going to solve on your own, right? I'm not going to solve this one. Again, a very simple question from the limiting reagent concept only. See guys, 3 moles of NaOH reacts with 4 moles of H2SO4. Find the limiting reagent. Simple. So at time t is equal to 0, I'm given with 2 moles of NaOH. At time t is equal to 0, I'm given with 3 moles of NaOH. And how many moles of H2SO4? 4 moles of H2SO4. This was going to be 0. This is going to be 0 because the reaction wouldn't have started yet. Okay. I just need to identify the limiting reagent. Isn't it a simpler one, right? See, just divide the given moles of reactants by their respective stoichiometry coefficients. Yeah, okay. The value comes out to be 1.5, the value comes out to be 4. 1.5 is less than 4, so NaOH is the limiting reagent. Done and dusted, right? No need to think over it. Yeah, so your NaOH is the limiting reagent. Let's move on to one more. This is one more question from the percentage yield, okay? I hope you remember how to calculate percentage yield. There is a formula to calculate percentage yield if you remember, correct? Percentage yield is always equal to experimental amount divided by expected amount multiplied by 100, yeah? Percentage yield, it's always equal to experimental amount divided by expected amount multiplied by 100, correct? Now people, how this question is to be solved, understand properly. See, on heating 40 grams of calcium carbonate, right? So basically I'm given with calcium carbonate and I'm heating this calcium carbonate up, okay? When I heat this calcium carbonate, it gets converted into calcium oxide solid and with this you get carbon dioxide gas as well, right? Well, as per the question, on heating 40 grams of calcium carbonate, 20 grams of calcium oxide was obtained. So this is something which has been observed experimentally. Experimentally, it has been observed that on heating 40 grams of calcium carbonate, 20 grams of calcium oxide was produced, correct? In order to calculate percentage yield of the reaction, I should know the experimental amount, I should know the expected amount, then multiply by 100, we'll be getting the percentage yield of the reaction. But the point is, see, I'm given with the experimental amount. See, this is experimental amount, right? This is something which has been observed experimentally in the laboratory. Now, what do I need? I need expected amount. How do I calculate expected amount? Expected amount will be calculated from stoichiometry. How come? Have a look. See, the reaction is already balanced. The molar mass of calcium carbonate is 100 grams. The molar mass of calcium oxide is 40 plus 16 is 56 grams, right? Right? Okay. So I got to know something as, from the stoichiometry I can say, 100 grams of calcium carbonate, it should produce 56 grams of calcium oxide. As per the stoichiometry of the reaction, I got to know something like this. 100 grams of calcium carbonate should produce 56 grams of calcium oxide. So I can say 1 gram of calcium carbonate should produce 56 divided by 100 grams of calcium oxide. Yeah. So 1 gram of calcium carbonate should produce these many grams of calcium oxide. So I can say 40 grams of calcium carbonate should produce 56 divided by 100 multiplied by 40 grams of calcium oxide. So these many grams of calcium oxide should get produced from the stoichiometry. I'm using the term should get produced. I'm using the term should get produced, right? Okay. These many grams of calcium oxide should get produced from the stoichiometry. If you solve this value, it will be, I guess, something as 22.4. So from the stoichiometry, I got to know 22.4 grams of calcium oxide should get produced, right? Should get produced. So this is something which I was expecting. This is the expected amount of calcium oxide which should have got formed as per the reaction. But actually, how much is getting formed? Only 20 grams of forming, right? So can I calculate percentage yield of the reaction? It's going to be expected amount divided by, experimental amount divided by expected amount multiplied by 100. Just solve it, get the percentage yield of the reaction. Yeah. It'll be, I guess, 89%. Is that? It'll be something as 89%. So 89% is the yield of the reaction. Or you can say it like this. You can say 89% of the expected amount. 89% of the expected amount is actually getting formed. 89% of the expected amount is actually getting formed. You can say that as well. Yeah. Right. Let me know in the chat box if it's clear to you. Let me know first. Yeah. Yes, Balaji, these are previously asked questions. These are previously asked questions. Should I move on? Yeah, should I move on to the next one? Perfect. Let's move on then. Okay, we have got one more question from the same percentage yield, right? You can solve it. You can give it a try. See, guys. As per this question, 1.12 grams of calcium oxide is reacted with the excess of HCl, okay, and 1.776 grams of CaCl2 is formed. What is the percentage yield of the reaction? Okay, first of all, in order to calculate percentage yield, what is the formula all about? Formula is experimental amount. Experimental amount divided by expected amount multiplied by 100. Well, in the question itself, it's mentioned that 1.12 grams of calcium oxide is reacted with excess of HCl and 1.776 grams of calcium chloride is formed, right? This is something which has been observed experimentally, right? This is something which has been observed experimentally. Experimentally, it has been seen that 1.776 grams of calcium chloride are getting formed, okay? Now, this is something which is experimentally determined, right? Now, I'll use the stoichiometry, and from the stoichiometry, I would calculate how much of calcium chloride would have got formed. It should have got formed, right? Okay. See how. Understand. The reaction is given to me, right? First of all, the reaction is balanced. It's a balanced reaction. If I ask you what is the molar mass of calcium oxide, it's going to be 40 plus 16, that's 56 grams. Molar mass of calcium oxide, that means mass of 1 mole of calcium oxide, right? If I ask you what is the molar mass of CaCl2, it's going to be 111 grams, right? So 111 grams is the mass of 1 mole of CaCl2. Can I say 56 grams of calcium oxide produces 111 grams of CaCl2, right? I got to know 56 grams of calcium oxide as per the stoichiometry should produce 111 grams of calcium chloride. Can I say 1 gram of calcium oxide should produce 111 divided by 56 grams of calcium chloride? Right? Okay. 56 grams of calcium oxide should produce 111 grams of calcium chloride. So I can say 1 gram of calcium oxide should produce these many grams of CaCl2. So can I say 1.12 grams? 1.12 grams of calcium oxide should produce 111 divided by 56 multiplied by 1.12 grams of CaCl2. So these many CaCl2 grams should have got produced, right? These many grams of CaCl2 should have got formed, right? And if you calculate the value, it will be something as how much? 2.22, is that? Okay, 2.22 grams. So 2.22 grams of CaCl2 should have got formed. So this is something which was expected amount, right? This is something which I was expecting that this much amount of calcium chloride should have got formed, right? So this is something which is expected, right? I have the expected amount, I have the experimental amount. I can simply calculate the percentage yield of the reaction. So percentage yield of the reaction is going to be equal to experimental amount, which is 1.776, divided by expected amount, which is 2.22, multiplied by 100, right? Okay, just get the value. It's going to be, I guess, 75 something, right? Or 80. Chalo, it's 80%, right? So 80% is going to be the percentage yield of the reaction. Or I can say 80% of the expected amount is actually getting formed. Yeah, I can say this as well. 80% of the expected amount is actually getting formed, right? Let me know in the chat box if it's clear to everyone, yeah? Let me know in the chat box if it's clear to every single guy, yeah? I want every one of you to say it fast. Let me know fast in the chat box if it's clear to everyone. Right? Let me know fast, just give me some green signal from the chat box. Give me some green signal from the chat box so that I can move on. Okay, perfect, guys. All right, so let's move on then. Let's move on to one more. Okay, calculate the amount of calcium oxide in kgs that can be produced on heating 200 kilograms of limestone, that is 90% pure calcium carbonate. Okay, see what the question says. We are given with a reaction, first of all, in which calcium carbonate, it gets converted into calcium oxide, and with this calcium oxide, you are getting carbon dioxide as well. Yeah. Calculate the amount of calcium oxide in kilograms. Calculate the amount of calcium oxide in kilograms that can be produced by heating 200 kilograms of limestone, that is 90% pure calcium carbonate. So basically, you are given with a limestone sample, and in a limestone sample, only 90% is present in the form of pure calcium carbonate. So I'll be first of all calculating the mass of pure calcium carbonate in the sample. The mass of pure calcium carbonate in the limestone sample. That is 90% of the total mass of the sample, and total mass of the sample is 200 kilograms. So out of 200 kilograms of the sample, there will be only 180 kilograms present in the form of pure calcium carbonate, right? So first of all, I got to know something as, in these 200 grams of limestone sample, there are 180 grams of calcium carbonate which is present in pure form. Okay, and in the reaction only pure substance participates. In this reaction only pure mass of calcium carbonate will participate, right? Okay, so we will have a look. If I talk about the molar mass of this calcium carbonate, it's 100 grams, mass of 1 mole of calcium carbonate. If I talk about what do I need to calculate? Calculate the amount of calcium oxide. Okay, what is the molar mass of calcium oxide? It's 56 grams. So can I say 100 grams of calcium carbonate produces 56 grams of calcium oxide? Or I can say in terms of kilograms as well. I can say 100 kilograms of calcium carbonate produces 56 kilograms of calcium oxide as well. Okay. Can I say 1 kilogram of calcium carbonate should produce 56 divided by 100 kilograms of calcium oxide? Okay. 1 kilogram of calcium carbonate is producing these many kilograms of calcium oxide. So can I say 180 kilograms of calcium carbonate should produce 56 divided by 100 multiplied by 180 kilograms of calcium oxide, right? So you got to know these many kilograms of calcium oxide are actually getting formed, right? Okay, so you got to know these many kilograms of calcium oxide are getting formed at the end of the reaction. As simple as that, yeah? Let me know in the chat box if it's clear to you. So people are saying it's 100.8, is that? Okay, so people are saying it's 100.8 kilograms of calcium oxide are getting formed at the end of the reaction, okay? Let me know in the chat box if it's clear to you. Give me some green signal from the chat box so that I can move on. Yeah? Right. Ashwita, I can understand a bit of Tamil. I can understand. Okay, because I have stayed in Tamil Nadu for almost 5 to 6 years. And you might be knowing Shimon sir, he's one of my good friends, you can say, the best friend you can say, right? So, he keeps on teaching me sometimes of the Tamil language. Yeah, should I be moving on? All right. Basit, I'm doing great. How are you? Bushra, I'm from Srinagar. All right, Pranavi, I'll be doing that. No issues. I'm from Srinagar, Jammu and Kashmir, yeah. Okay. So let's move on to one more question then, yeah? Okay, the question from molarity, right? Concentration terms. See guys, understand. Dissolving 120 grams of urea, whose molecular weight is 60 grams per mole in 1000 grams of water, gave a solution of density 1.15 grams per ml, the molarity of the solution will be. First of all, I'm supposed to calculate molarity of the solution, which is going to be number of moles of solute divided by volume of solution in liters, or let me write the formula only. Molarity is equal to mass of solute in grams, W2 in grams, multiplied by 1000, divided by molar mass of solute multiplied by volume of solution in milliliters. This is the formula which is used to calculate molarity, right? Okay. Now we will see. What is mentioned in the question? Dissolving 120 grams of urea in 1000 grams of water. So first of all, I'm dissolving 120 grams of urea in 1000 grams of water. Urea is present in lesser amount, so urea is my solute. And I'm given with the mass of solute, which I'm representing by W2. It's given to me as 120 grams, right? I'm given with the mass of solvent as well, which is given to me as 1000 grams, okay? So first of all, can I calculate the molar mass of urea, molar mass of solute? Molar mass of urea is going to be 60 grams per mole. Remember, the molecular formula of urea is NH2CONH2. You can calculate its molar mass, yeah? NH2CONH2, it is the molecular formula of urea, correct? Now we will see. In order to calculate molarity, I should know the value of W2, which is given to me. I should know the value of M2, which is given to me, but I do not know the volume of solution. So let's try to calculate the volume of solution first, yeah? I can say density of solution is equal to mass of solution divided by volume of solution, yeah? What is the density of solution that's given to me? The density of solution is given to me as 1.15 grams per ml, yeah, is equal. Mass of solution is given to me. Mass of solution means mass of solute plus mass of solvent. That's going to be 1120 grams divided by volume of solution. So from here, you can clearly calculate the volume of solution. It's going to be 1120 divided by 1.15, yeah? It's going to be 1120 divided by 1.15 milliliters, correct? So this is basically the volume of the solution in milliliters. I got the volume of solution in milliliters as well, right? Okay, now put all the values in this equation, you'll be getting the molarity, which is going to be equal. W2 is the mass of solute, which is 120 grams, multiplied by 1000, divided by molar mass of solute is 60 grams, right? Multiplied by volume of solution in ml is 1120 divided by 1.15. When you solve it, you get the value as 2.05 molar. So molarity of the solution is 2.05, which you were supposed to calculate, yeah? You can let me know in the chat box if it's clear, right? Molarity of the solution is coming out to be 2.05. Let me know fast. No Captain America. Yesterday I didn't take any class. Walaikum Assalam, Umar. Okay. Should I be moving on to one more then? Should I be moving on to one more? All right, so let's move on then. Let's move on to one more question. This is a simple question. You can solve this on your own, I'm sure. Calculate the mass of NaCl required to produce 100 ml of semi-molar solution. Molarity of the solution is given to me as 0.5. Okay, semi-molar means molarity is 0.5. Mass of solute, I'm supposed to calculate. Volume of solution is given to you, right? This is something which you can solve on your own also, right? Molarity is equal to W2 multiplied by 1000 divided by M2 into volume of solution in ml, correct? Molarity is given to me as 0.5. W2 we are supposed to calculate. Molar mass of NaCl is 58.5. You can get the value as 2.92 grams, right? This is not something which I'll show over here. This is a very simple and basic question. I think the same question is repeated, yeah? The question which I solved just now, it's repeated, correct? Yeah, it's repeated. Okay, one more question we have. See, 6.02 into 10 raised power 22 molecules of urea, okay, are present in 100 ml of its solution. The concentration of the solution. Concentration, nothing means concentration means molarity. That's it. Concentration means molarity. Whenever in the question, they'll ask you to calculate concentration, remember, you're supposed to calculate molarity, right? Okay, so molarity is number of moles of solute divided by volume of solution in milliliters multiplied by 1000, right? You can use this formula as well. Okay, so number of moles of solute is going to be equal to number of molecules of solute divided by Avogadro's number. Number of molecules of solute is 6.022 into 10 raised power 20 divided by Avogadro's number is 6.022 into 10 raised power 23. So these are basically the moles of solute, right? Whole divided by volume of solution in ml, that is 100 multiplied by 1000. Right? So 00 cancelled, 6.02 cancelled, 10 raised power 20 divided by 10 raised power 23, it goes up, it's going to be 10 power minus 3 multiplied by 10, the value is going to be 10 raised power minus 2 molar. So 0.01 is the molarity of the solution, 0.01 is the concentration of the solution, yeah? Right? Right, let me know in the chat box if it is clear. No, there is no mentee today. Who told you there's mentee? Right? This was a very simple question. It is just whenever you are supposed to calculate concentration, remember you are basically supposed to calculate the molarity, right? Okay, they might confuse you like this as well. Okay. Calculate the weight by weight percent of 1.5 molar CH3COH solution whose density is this much. See guys, there's a one direct result. Molarity is equal to 10 multiplied by density of solution multiplied by weight percent of solute divided by molar mass of solute. Solute is your CH3COH, okay? What is the molar mass of CH3COH? It's 12, 24, 24 plus 4 is 28, 28 plus 32 is 60. So 60 grams per mole is the molar mass of solute, first of all, yeah? See, what am I supposed to calculate? I'm supposed to calculate weight by weight, is that? Yeah, weight by weight percent of solute I'm supposed to calculate. Molarity is given to me as 1.5. 1.5 is equal to 10 multiplied by density of solution 0.8 multiplied by weight percent of solute divided by molar mass of solute is 60. So from here you can calculate the weight by weight percent of solute and it will be approximately something as 11.2. So 11.2 is basically the weight by weight percent of solute which I was supposed to calculate, right? Okay, everything is given, just solve it, get the value, right? Very simple question. Okay, calculate the molality of the solution. Guys, this is going to be the last question of the today's session, yeah? Right? Maybe there might be one more question after this. I don't remember exactly. Yeah, there will be one more question after this, I guess. Calculate the molality of Kcl. Calculate the molality of Kcl solution prepared by dissolving 7.45 grams of Kcl in 500 ml of solution, given that density of solution is 1.2 grams per ml. So basically I'm supposed to calculate molality of the solution, which is basically mass of solute in grams multiplied by 1000 divided by molar mass of solute multiplied by mass of solvent in grams, right? Okay, so we will understand. First of all, I'm given with KCl. I have got a solution containing KCl as solute. So mass of solute is given to me. Mass of KCl, mass of solute is given to me as 7.45 grams, right? What about the molar mass of KCl, molar mass of solute? Potassium is 39, right? Chlorine is 35.5. So the value is going to be 74.5 grams per mole. So molar mass of solute is also, I know, right? Molar mass of solute also I know. Volume of the solution, even I know. Volume of the solution is given to me as 500 ml, correct? So see, I need to calculate molality. See, what all parameters do I need? First of all, mass of solute I need, which is given to me. Molar mass of solute I need, which is given to me. W1, mass of solvent I need, first of all. Mass of solvent, right? How do I calculate mass of solvent? See, density of solution is given to me as 1.2 grams per ml. So density of solution is going to be mass of solution divided by volume of solution. It's given to me as 1.2. So mass of solution, I can write mass of solution is going to be equal to 1.2 multiplied by volume of solution. Volume of solution is 500 ml. So you get the value as 600 grams. So 600 grams is the mass of solution. 600 grams is the mass of solution. Well, people, you got the mass of solution. Mass of solution is nothing, that is mass of solvent plus mass of solute. It is basically 600 grams, right? Mass of solute is given to us as 7.45. So you get the mass of solvent right here as 592.55 grams. So this is basically the mass of solvent which I need in this equation, right? Okay. So people, the equation is done. Molality is equal to W2. W2 value is 7.45 multiplied by 1000 divided by molar mass of solute is 74.5 multiplied by mass of solvent is 592.55. The value will be approximately 0.166, something like this, 0.66 or 0.166. Yeah, this is going to be the molality of the solution, right? So I'm sure it's clear to you, right? Yeah, 0.168 is going to be the molality of the solution, correct? Let me know fast if it is clear to everyone. Yeah, right? People, this is the question which is going to be your homework, right? Right? I'm sure you would have enjoyed the mole concept in one shot, right? This is the question which is going to be your homework. You are going to let me know the answer of this question in the comment box right after the session, okay? Give it a try. So I'm sure all these things would be clear to you. Your mole concept would have got revised, I'm sure, right? So tomorrow we are going to continue with the isomerism. It's going to be session number 4, lecture number 4 or lecture number 5, something like that from isomerism, right? Okay. And we'll keep on having these one-shot series as well, right? Like once in a week or 2 times in a week, we'll keep on having these one-shots so that you revise the earlier sessions, right? Which we have taken on the same channel. So with this, I'll take a leave. People, the ones who have not joined in to the crash course yet, do get enrolled in the crash course. The link is there in the description box. Do not forget to use the coupon code as WSNEET if you want me to train you personally, okay? Yeah, there's a link in the description box of the video. Click on that link, right? And use the coupon code WSNEET if you want me to train you personally. Do not forget to do that because that's going to be the last option and the last beneficial option which you can have right now, okay? So do get enrolled. It's going to be highly beneficial for you. So the ones who have not liked the video yet, please and please do like the video, right? Basically, Captain America, I have got some headache, bro. That's why I'm ending the session right now. Otherwise, I would have solved 5 more questions, right? Okay. Hari, I take session at 7 p.m., okay? 7 p.m. I take the session normally, right? Vena atomic structure will be done next week. Okay. Hello, Vedic Maths by Tushar. What's up? Okay, the ones who have not liked the video yet, please and please do like the video. Do share the video with your friends and do not forget to subscribe to the channel as well. It was nice meeting you. I'll see you guys tomorrow at the same time. Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.